You are watching one of a series of videos giving an introduction to OrcaFlex. The first 4 of these videos, which we've called the fundamentals, are those that we would regard as prerequisites for looking at any of the other subsequent topics. If you are already familiar with these fundamentals, you may want to pick and choose the subsequent videos you watch based on your area of interest. If you're a complete beginner with OrcaFlex, I would strongly encourage you to watch the full series in order, as this will give you a good basic overview of the program, how to navigate it, and where to access and input data. It goes without saying that the quality of any OrcaFlex analysis is only as good as the quality of the input data, and that, of course, relies on the skill and experience of you, the user. These videos will help you to learn how to use OrcaFlex as one of your analysis tools, and I do hope that you find them educational and maybe even a little bit enjoyable too. In this session, we will look at creating a data file. So we're going to learn how to build a basic model and then save a data file. We'll start with a new instance of OrcaFlex, and you can see before we even do anything that there is already a sea surface and a seabed in the 3D view. This means that there must be, for example, a seawater depth defined. Now I can check what this is by using a measuring tape built into the program. And this is a simple tool which doesn't save any information but can be really useful for getting a good idea about distances and angles. If I position my cursor somewhere close to the sea surface, hold down the Shift and Control keys and then drag a line down towards the seabed, you can see a distance and an angle to horizontal appears next to the cursor. So we can see that distance is approximately 100 meters. If I then go to the environment data form and to the seabed page, sure enough, there's the confirmation that that depth is 100 meters. There are a number of other default parameters built into OrcaFlex when you first open it. For example, a 7 meter, 8 second Dean stream wave. So you do of course have to be very careful that properties like this are appropriate for the model that you are building. For now we're going to leave all of that information as it is. So let's add our first object, a vessel. So we select it in the toolbar by clicking on the vessel icon, and this gives us a crosshair in the 3D view as well as the message Place New Vessel. Clicking once in the view places the vessel on the sea surface vertically below the cursor. I can click and drag the vessel around the sea surface, and at the moment I don't need to place it in a specific position. Next we'll place a second object, a line, into the model. We select the line in the toolbar, and this time when we click in the 3D view, one end of the line will be placed exactly where the cursor is. Again, it doesn't matter at this stage where exactly the line is placed. Now that we have 2 objects in the model, let's connect them together. We actually have a couple of choices about what to do now. Do we want to connect the vessel to the line, or the line to the vessel? Well, there's not necessarily a right or wrong answer, but you do need to give careful thought to the ordering of the connections. In other words, the parent-child relationship. So let's take a look at both options and see which gives the most desirable relationship in this case. First, we will open up the vessel data form by double-clicking either on the vessel in the 3D view or on the vessel in the model browser. We will then go to the Connect to Object options and select Line 1. In the 3D view, the vessel has immediately jumped towards the line, and if we try and click and drag the vessel, the child, its position is now restricted to follow the path of the line, the parent. And if we click and drag the line, it moves and drags the vessel along with it in a fairly unorthodox way, and probably doesn't represent an appropriate parent-child relationship in this case. Let's try again, and I'm just going to use the undo facility to get back to my original state. So this time, instead of connecting the vessel to the line, we will connect the line to the vessel. I'll double click on the line in the 3D view to open up the line data form, and this line data form shows that we have 2 connection points for a line, end A and end B, both of which initially say fixed. This means that the line is fixed at both ends relative to the global coordinate system, we'll change the connection at end A to vessel 1. Take a look at the line in the 3D view while we do this. There is a green triangle at the left-hand end and a green circle at the right-hand end, representing the line connection points. The green colour indicates that both of these connections are currently fixed to the global coordinate system, which is coloured green by default, with the triangle representing end A and the circle end B. The colours used in OrcaFlex, such as green for the global axes, are default settings, but these can be changed by the user. You'll also find colour options on the drawing page of each object as well. If I just go to the general data form and the drawing page, we can see this is where we define the green colour for these global axes. So back to the line data form, we'll go back to end A again and change the connection point from fixed to vessel 1, and you'll see the triangle at the left hand end of the line change from green to red. The colours of the connection points depend on the object they're connected to, and because the vessel object is red in this instance, the end connection point is also red. If the vessel colour was subsequently changed, then the connection point colour would change also. Now that the line is connected to the vessel, if we drag the vessel, we can see that the end of the line is moving with it, and this is the desired behaviour on this occasion. You'll see as well that these two objects form a rigid connection, and this is regardless of the distance from that line end to the drawing of the vessel. If we open the line data form again, we can set the position of that end A connection relative to its parent object, which is the vessel in this case. So, whereabouts on the vessel is the line positioned? Let's set it to 0, 0, 0 and find out. We're going to use a new set of axes now called the local axes. Every object has its own set of local axes, and these can be turned on from the Axes and Labels menu. This menu is available either from the View menu or from the pop-up menu in the 3D view. With the local axes now turned on, we can see that the line end is now positioned at the origin of the vessel axes. And if we then open the vessel data form and set its free connection position to 0, 0, 0, then the vessel is then positioned with its local axes coincident with the global origin. In reality, we don't want the line end to be positioned on the vessel axes like this, so since the line is the child object, we can just click and drag it and move it away. And we can see if I hover over the line, there is a tooltip which pops up which tells me which end my cursor is closest to. So at the moment my cursor is closest to end B, and now the tooltip indicates it's closer to end A. The exact position of this end at the moment isn't important. We'll come back later on and position it more accurately. The other end of the line now needs to be positioned on the seabed, which is fixed in terms of its depth below the global origin. So we could in theory leave the line end as fixed and just position it at the same depth as the seabed, 100 meters. On the line data form, we go to NB, which is fixed, and in the Z value for NB, just set that to -100. And this places the line in a fixed position at the same depth as the seabed. This seems okay, but does leave us with a few potential issues. Firstly, if we were to change the seabed depth, let's say it should have been 110 meters rather than 100 meters. If I double click on the seabed, this brings up the environment data form, and I'll change the depth to 110. We can see the seabed has dropped, but the line has remained at 100 meters depth. So we would have to go in and change the line end position also, so that's an extra step. I'm just going to use the undo facility to bring that depth back to 100 meters. The other problem occurs when we look at seabeds which are non-horizontal. Let's say we have a slope on the seabed of 10 degrees. We can now see that the line end is actually below the seabed. So that seabed depth of 100 meters is the point vertically below the global origin, so around here. We'd have to think very carefully about what depth that fixed NB position of the line would have to be in order to be resting at the correct point on the seabed. Again, I'm just using the undo facility there to put my seabed horizontal again. The other issue is a little more subtle and requires us to zoom in on the line end. I'm just going to move end A of my line just to allow my line to bend slightly. And just so I can look a little more clearly at the line end, I'm going to turn off the local axes. So in the pop-up menu, if I select Axes and Labels and unselect the local axes, we can see the nodes on the line represented by a circle. And with our line end fixed at -100 meters, that places the center line, the axis of the line, exactly on the seabed. And that means that part of the line is actually buried below the seabed, because a line has a diameter. What we would ideally like to do is have the line resting on the seabed. So if we go back to the line data form, instead of fixed, we're going to use an option called anchored. And when we select anchored, the line end changes colour. You can see it's green currently, and when we select anchored, it changes to brown. And that's because that line end is now connected to the seabed, which in this case is coloured brown. And as I mentioned earlier, the colour of these line end connection points depend on the colour of the object they're connected to. So with the anchored option selected, we now have a new item which we can use called height above seabed. We see this as a negative value at the moment, and if I set this to 0, we can see that that moves the line end so that it's resting on the seabed instead of being partially buried. And now if we change the seabed depth again, we can see that that line end actually follows. Similarly, if we were to put a slope back in, again, that line end will follow the position of the seabed. So I've just used Ctrl-T shortcut to go back to my default view. Let's now position the ends of the lines more precisely, and also set the length of the line to suit the new end positions. So we'll use the data on the screen now to do this, and I would encourage you to pause the video at this point and have a go at setting this data independently before I show you. So hopefully you've had a go at doing this yourselves, but I will run through it now. First we'll set the line length to 200 meters. This is done either by double-clicking on the line itself in the 3D view, or double-clicking on the line in the model browser. So we go to the structure page and set the section length to 200 meters. What you will see is that the length is immediately extended in the 3D view. Then we need to set the end positions. End A is fairly straightforward. We just need to set the X, Y, Z values for the hang-off position. It's relative to the vessel because line end A is connected to the vessel. So that sets the position of end A, and then we need to set the position of end B, which is slightly more complicated. This is because the given data specifies a horizontal distance from hang-off to anchor of 155 meters. But because NB is anchored, that means its positions are relative to the global coordinate system, not the local coordinate system. So because the anchor point is relative to global, we need to remember to add 35 meters, which is the position of end A from the global coordinate system, onto our specified value of 155. So the x value of NB should in fact be 190 meters. The z value at NB is already specified because we previously set that height above seabed of 0. At this point, it's worth noting that we have a default setting of 10 meters for the segment length of a line. You can see that setting here on the structure page. You may remember from an earlier video that this is the length of the straight massless segments between the line nodes. And in a model such as this, the default 10 meter line segmentation is too coarse. If we zoom in on the touchdown region, you can see visually that the curve of the line is not well represented. We will look at how to refine this in a later video. Before we move on, I'd like to share a couple of useful tips with you. The first is a quick method of connecting objects together. The method we've used so far is to open up a data form, such as this line data form, and then select the object that the line needs to be connected to from within the data form. I'm just going to temporarily set line end A connection back to fixed, and then I'll show you a different method. So we can see that the end A connection point has turned from red when it was connected to the vessel back to green, indicating that it's fixed to the global coordinate system. So to reconnect the line end to the vessel, the first thing I need to do is select the line with the left mouse button. So I click once. When the line is selected, you can see in the status bar it says select line 1 end A. Then I need to hold the control key and use the left mouse button to click on the vessel. And now we see a message in the status bar that says connect line 1 to vessel 1. And you'll note as well that the triangle at the end of the line has now changed from green back to red, which again shows us the connection to the vessel, which is red. The second thing I want to make you aware of is a setting for the model browser called View by Groups. Now I have this already set. You can see in the model browser pop-up menu, the View by Groups option near the top is selected. In a new installation of OrcaFlex, this is not activated, so if I turn this off now, what we instead see is that objects are grouped by their type in the model browser. This model only has one vessel and one line, but you can see that we have a group called vessels and a group called lines, and any additional vessels or lines would be placed automatically into these subfolders. Having View by Groups enabled gives you the benefit of being able to create your own subgroups, which you can then use to drag and drop objects to organize your model. This becomes very helpful when you have a more complicated model. For example, if I use the pop-up menu in the model browser, now that I have View by Groups enabled, I can actually add my own group, which gives me a new subfolder. I can rename this subfolder in the normal Windows fashion, and then I can simply multi-select objects in my model browser and then drag and drop these into that new folder. You'll see that I used the usual Windows method for naming that subfolder. I can in fact use the same methods for naming objects as well. So in the model browser I can select an object once and then select it again with the mouse button, and that gives me the option to rename. I can also use the pop-up right-click menu, select rename, and I can also use the F2 shortcut key. So I'm going to give this object a different name, just so I can differentiate it from other lines that will be added into this model at a later time. We've now built the first stage of this riser model, and it's important to save our work. There is no autosave feature in the program, so you do need to remember to save regularly. We haven't yet run a simulation, so we have no results to save. We do, however, have the model data, and this can be saved in two formats. The first type is the binary data file, which has the .dat file name extension. This is the default and preferred file type, and it has strong version compatibility. It also contains all data in a model, whether active or inactive. The second format is the text data file, which has the .yml file name extension. This contains only the active data in a model, and version compatibility isn't as strong. However, it can be a useful file type in certain circumstances, such as the modification of existing files with minor variations like weather conditions. It is also a useful file type for QA and archival purposes, as it can be viewed using standard text editors and text comparison programs. So we will use the default binary data file format, and I'll give my file a name, my riser, and hit save. So far we've worked on our model using a single 3D view. Sometimes it can be helpful to look at a model from different angles, and we've seen the various view navigation options already, but it is also possible to have additional views open in parallel. In fact, there is no limit beyond the practical limits of Windows real estate to how many views you can have open at the same time. We'll add a second view now to this model so that we can see the elevation and plan views simultaneously. I simply need to go to the toolbar and click on the eye icon. Alternatively, in the window menu, I can click on Add 3D View or use the Ctrl 3 shortcut. Now that we have a second view open, we just need to set the orientation. You can see that it comes in at the same default orientation as the first view. I just need to go to my view and use the pop-up menu and then select the plan view. Remember, this can also be accessed using the Ctrl P shortcut. These views can be tiled either horizontally or vertically. Currently they're tiled vertically, so we can go back up to the window menu, and if we want to, we can select the tile horizontal option. I'll add a third 3D view in as well, so I'll go back to the Add 3D View icon in the toolbar. So we currently have a plan view and an elevation. Perhaps I'll add a shaded graphics view as well. Remember, this can be accessed with the Ctrl G shortcut, and I'll just orientate that view as well. So we've got three nice views of the model now, and having these multiple views is great, but when you close and reopen a model, you will return to the single default view. But the good news is we can save any combination of views as something called a workspace file. This is done from the workspace menu. We can save multiple workspaces. We just need to go to the Save Workspace option and choose a name for that particular workspace file. You can see that it's suggested a default file name which is the same as the data file, so we'll use that option in this case. As soon as we've saved a workspace file, we can close all of the windows, and when we go back to the workspace menu, we can see that previously saved workspace file available in a list, and if we select it, then all of the views will open back up as they were before. You should now have a basic understanding of how to create an OrcaFlex data file. The next video will focus on running a simulation.